Good morning, dear students. In the last video, we have just started floating and sinking. Floating means when an object or body remains at the surface of any liquid or fluid. Fluid is the combined word used for liquids and gases, right? And sinking means when an object or body goes deep down at the bottom of the liquid. Let us discuss more about floating. Why do things float? Things float if they are less dense than the fluid they are in. You have learned about density. What is density? Density is mass per unit volume. Its unit is kg per meter cube or gram per centimeter cube. Right, let us take a very simple example of ice and water. If I take a glass of water and drop a ice cube in it, what will happen? Ice cube will float in water. That tells us that the density of ice is less than that of water. One more example. If I have a solid iron ball and water, so if I drop solid iron ball in water, it will sink. But if I'll drop the same solid iron ball in mercury, then it will float. This tells us about the density of iron, water, and mercury. Since in water it will sink, the density of solid iron ball is more than that of water. But in case of mercury, it will float. That means it is having lesser density than mercury. So, whenever the things or the objects are less dense than the other liquid or fluid, then they will float. Things float if they weigh less than the buoyant force pushing up on them. And the things float if they are shaped so that the weight is spread out. You must have seen large or huge ships, right? Although they are very heavy, but they float in water. Why? Because their weight is spread out in such a way they are hollow so that their density decreases and they will float in water. To understand second point better, let us see the principle of flotation. When a body is immersed in a liquid, that means whenever a body is inside, partially or completely in a liquid, the following two forces act on a body. Number one is weight, number two is buoyant force. We will discuss these two forces now. Now these two forces are in opposite direction. Buoyant force act in opposite direction of weight. You have learned in class 7 the difference between mass and weight. Do not confuse weight with mass. Mass is the matter contained in a body or an object, but weight is a force which acts in downward direction and that is caused by the gravity of earth, right? So what is the direction of weight? That is a force. The direction of this force is downwards. What is a buoyancy force? Buoyancy force is an upward force which is applied by any fluid when we try to immerse an object in it. You can take an example of a ball and water. Suppose you have a tub filled with water and you try to immerse a ball in it. Now, when you are trying to push that ball inside the water, you will experience that you have to apply some force to get it inside the water. Now, why this force is required to immerse it inside the water? Because an upward force is applied by water. Now, this upward force is known as buoyant force. It is also known as upthrust, and it is represented by FB. F is the force, B is buoyant. So, buoyant force is denoted by FB. Right? So, let us again recall weight is a force which is acting in downward direction, and buoyant force is again a force which is acting in the upward direction. Weight of the body is applied by the body and it is due to gravity, and buoyant force or the upward force is due to liquid. Now, what causes buoyant force? Just read it. Buoyant force is the upward force on an object exerted by the surrounding fluid. As I've told you just now, when an object pushes water, the water pushes back with as much force as it can. That is the buoyant force or the upthrust. If the water can push back as hard, the object float, and if not, it sinks. Right? Now, on the basis of that weight and buoyant force, we have three cases. Now, the object is applying weight and the liquid or the fluid is applying the buoyant force. Now, we have three different cases. In some cases, weight of the object is more. In some cases, buoyant force applied by the liquid is more. So, first case is positive buoyancy. This name is not given in your book, just cases are given, so you can consider them only. First case, we have weight of the body is less than the buoyant force. That means buoyant force applied by the liquid is greater. So it will not let the body to sink in it, to get inside it, to get immersed in it. That means the body in this case will float with the more portion outside the liquid. Right? Buoyant force is greater than weight, so the object float. Because in this case, upthrust is more, upward force is more, so it will not let the body get inside it completely. It will not let get it sink in the liquid. Next case, we have neutral buoyancy, when the weight of the object is completely countered or balanced by the buoyant force. Now, in this case, what will happen? The object is suspended in the fluid. Suspended means it will remain afloat, but it, it is completely inside the liquid. It will not sink. It will float, but inside the completely inside the liquid or the fluid. Third case, we have negative buoyancy. In this case, weight of the object is more than the buoyant force. That means net force or the total force will be in downward direction because weight is more, right? So what will happen when the weight is more? The body will sink or the object will sink. In your books, it is not given in greater, it is not written like this, weight is greater than point force, but the difference is given, right? So you can consider that only, although both are similar. Next we have, how do we calculate buoyant force? This buoyant force is equal to the weight of the displaced fluid. Whenever a body get immersed in any fluid, or to make it simple, let us call in any liquid, what will happen? It displaces the liquid to take its space. You must have noticed when we place a stone or we drop a stone in water, what will happen? The water level in that container, in that glass, will rise up. That means some space is taken by that stone, and that displaces the liquid from its place. So that buoyant force, that upward force, is equal to the weight of displaced liquid. Or this buoyant force can also be calculated by the weight of an object in air, which is the actual weight, which is the true weight, which is the real weight of the object, minus the weight in water or any liquid.